Hi guys, Mr. Rocco here. Hope you're doing well. This will be one video this week on Kepler's first law, and there'll be two assignments. One is called the eccentricity worksheet. That one you're going to have to print with your printer and then use your ruler and a calculator to complete that worksheet, and then take a picture of the worksheet and submit that on Canvas. So print the eccentricity worksheet out, use your ruler, use a calculator, and take a picture of that one. The other worksheet is Kepler's first law worksheet, which is 10 multiple choice questions. Same as always, to the left of each number is a box, and you can type your answer right there, and then just save that PDF and submit that. All right, so let's get right into Kepler and other astronomers. So we're going to go through a little bit of history here briefly on some important astronomers throughout our history. Before we do that, there's two theories about the solar system, how the solar system is set up. The solar system, and this is a different number that you have to know, excuse me, the solar system is 4.6 billion years old. So that would include our sun and our planets. Don't confuse 4.6 billion years for our solar system with the approximate age of the universe. The universe is 13.7, 13.8 billion years old. So the Big Bang, right, created the universe. That was 13.7 billion years ago. And then it took almost 9 billion years later before our star, our sun, and our planets came. So anyway, the theories are geocentric and heliocentric. Geo, the prefix geo means earth. Like when you study geology or geography, you're studying the earth. And so it was an earth in the middle. So it put earth in the center of the solar system, and it put the planets and the sun and the moon orbiting us. So we were in the center. This goes back to a gentleman named Claudius Ptolemy. It was actually called the Ptolemy system, same thing. And this was around 90 AD. This was heavily believed by people at that time, especially the Roman Catholic Church. They were a very powerful church at the time, and so they would preach to people that we're in the center, the earth is the middle, and everything revolves around us. And that was just from looking at simple observations. They saw the sun go across the sky, the moon goes across the sky, stars, constellations. So they said, well, we must be the center if everything seems to be going around us. Now, you go into the middle 1500s, and a gentleman named Nicholas Copernicus. And Copernicus comes along and says, nah, Roman Catholic Church, you're wrong. And Ptolemy is wrong. And he comes up with a different system called the heliocentric model, which is the model we follow, obviously, today. Helio comes from the Greek word helios, which means sun. And so here now it puts the sun in the middle and all of the objects, Earth and all the planets, everything revolving around the sun. And again, this goes to credited to a gentleman named Copernicus, Nicholas Copernicus. This is a picture of Ptolemy. He was a very big Mets fan. Made some predictions which were usually wrong, but hopefully this prediction will not be wrong. So it says, who was Ptolemy? One of the most influential Greek astronomers, geographers, and mathematicians of the time, Claudius Ptolemy supported the geocentric theory. Around 140 AD, Ptolemy documented the most detailed explanation of the structure of the universe at the time. His detailed theory was known again as the Ptolemy system. This system was based on the belief that all heavenly bodies, including stars and planets, were attached to spheres which rotated around the Earth. It was believed that the order of the planets from the Earth were, so again, you put the Earth in the middle, and then it went Moon, being that it was the largest object in the sky, Mercury, Venus, then the Sun, then Mars, Jupiter, Saturn, other stars, which we know is not the correct order, but that was what Ptolemy came up with. This is a picture of Nicholas Copernicus, huge Jets fan, and we won't talk about Jets. So this is just a diagram to show the difference. So the geocentric model puts Earth, this would be Earth right here in the middle, put an E, and it puts the sun, the moon, and all the planets revolving around us. And then the heliocentric model puts the Earth and other planets going around the sun, which is the model that we know is correct today. These are some of the criteria that Copernicus came up with why the heliocentric model is better than the geocentric. Puts the sun in the middle. It put the planets in the proper order: Mercury, Venus, Earth, Mars, Jupiter, Saturn. So that was important. It puts the moon orbiting the Earth instead of the moon orbiting the sun. And it assumes that orbits are almost a perfect circle, which they're not. We're going to talk about that. They're called ellipses, which is like an oval, but we'll get into that later in the video here. It also explains what's called retrograde motion. Retro, right? If you think of retro music or retro clothes, right? You're going back. You're wearing clothes from the 60s, the 70s, the 80s, the 90s, going retro. Retro motion is what planets actually, some of them will do. And this animation I'm going to show you, hopefully we'll show that to you. In the geocentric model, retrograde motion was not as easy to explain. So let me pull up this animation here. Hopefully this will make sense. So what you're looking at here, you got the sun in the middle. Of course, this green ellipse or oval is the Earth's orbit. This blue orbit is Mars, right? Mars is further from the sun. And what's going to happen is as the Earth and Mars revolve around the sun, we move a little bit faster because we're closer to the sun. So, and that's another one of Kepler's laws we'll get into. Very easy law. The closer a planet is to the sun, the stronger the gravitational pull and the faster that planet goes. So because we're slightly closer to the sun than Mars, we move faster in our orbit than Mars. Mars goes slower. So if you're looking at this sort of reddish or pinkish, purple, whatever color line here, you're on Earth, we're on Earth, looking at Mars amongst the background of all the stars up here. So if you watch where Mars is here, I'm going to start the animation. What's going to happen is we're going to move quicker. And as we move faster and we start to pass by Mars, Mars is going to appear, and again, it's not really doing it, it's going to appear to go retro. It's going to go backwards. So Mars is going to move in one direction, and then it's going to appear to go backwards. It's going to do a little loop. So let me start the animation. You'll see what I mean. So here we come. We're going to eventually now go faster. And notice what Mars is going to start to do. It's going backwards. Now, is it really going backwards? No. We passed it. And now it starts to go forward again. It starts to go back to the east. So let me start and restart that again. So it's going to go east. It's heading left to the left. Then when we pass Mars, it's going to appear to turn around and go west. Go to the right for a little bit, and then eventually turn around and go the other way. Now, again, Mars isn't really doing that. It's just while we pass by because we're closer. So let's hit the start. So it started, you see in the beginning, it was going to the right, or excuse me, to the left. Now it's going retro. It's going backwards. And then it slows down and it starts to go back to the east again. So it does this little loop. Do one more time. So it goes east. Now you see over here we're passing by. So as we go faster, it appears to go that way, retro. And then turns around and goes east again. And this could only be explained, well, the best way to be explained is if you put the sun in the center. Now, Ptolemy, let me get back to my notes here, tried to explain this. And this is what he came up with. So when they asked Ptolemy, they said, well, how can you explain retro? Why does a planet, go in one direction and then loop back and then go forward again? How do you explain this loop right here? And he called them epicycles. And so what he said is, he put Earth in the middle now, remember, geocentric model. He said a planet will go around in its orbit. It's going around, it's going around, it's going around like this. And then it does a little mini loop. So it'll actually do a physical loop like that backwards, and then it'll go around, 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 and then do another epicycle, another little mini loop. So he's saying inside of the main orbit are these little tiny mini loops that planets will kind of loop-de-loop, and that's why they're showing that retro. They're actually physically making these little loops every so often, which is ridiculous, but that's the only thing Ptolemy could come up with, is these epicycles to try to explain the retrograde, which didn't work. This just shows the same thing. So this is January, February, March, April, May. So this would be our orbit. This is Mars' orbit. So in January, you look at Mars, it's this black dot up here. February, it's orange. So again, it starts out going in the correct direction. But then when we get to March and April, we are going faster than Mars. It appears as if Mars does this, turns around and goes backwards, and then loops back again. So this little section right here where it does a little zigzag like that is the retro part. But that's only happening, again, because we're going faster and Mars is going slower, which makes sense, putting the sun in the middle. Now, after you got Ptolemy and Copernicus, you have Taiko Brahe. He was a Danish astronomer. He goes down in history for a few things. He built the first observatory. A lot of your mountaintops around the United States and the world, a place like Hawaii have these. There's one over in the Catskills too. They're these huge observatories where the telescope will come sticking out of here and they can look at the stars and planets and stuff. So he goes down as building the first one. He was the boss, or the boss to Johannes Kepler. Kepler's the guy we're going to talk about when we get to his first law. So Tycho Brahe is Johannes Kepler's boss. And he actually came up with a third system. So you have the geocentric system, which is Earth in the middle. You have the heliocentric system, which puts the sun in the center. Tycho comes up with his own model. He does a little bit of both. He combines them. So it says Taiko Brahe's model put the Earth in the center. Here's the Earth, with the sun and the moon going around us. So here's the moon going around us. Here's the sun going around us. But he then had all the other planets, Mercury, Venus, etc., going around the sun. So it was kind of a combo thing. He had a little bit of helio and a little bit of geo. So he had the sun and the moon going around us, but then he had all the other planets going around the sun. So he put both models together, which again isn't the correct model. This is a picture of Taiko Brahe. This ruffle thing, which I always wondered, what is that? These guys were around in the 1500s. It was called the ruff, R-U-F-F, which was worn, it says, by men and women, children, served as changeable pieces of cloth that could themselves be laundered separately while keeping the wearer's doublet or gown from becoming soiled at the neckline. The stiffness of the garment forced upright posture, so it kept them in good posture, and their impracticality led them to become a symbol of wealth and status. So people in the 1500s that wore this thing called the ruff, that's supposed to show, nobility and wealth. And anyway, you see a lot of pictures from that time where they wore that thing. It's called the ruff, R-U-F-F. Another guy, Galileo. Him you've probably heard of. So Galileo goes down as what they call the father of astronomy. He was actually a math teacher. He was like a Miss Peck or Miss Fuchs. So he was a math teacher in Italy. He also invented the scientific method. So when and I don't really spend much time, middle school you probably did, where you have to do what's the purpose of the lab, the hypothesis, the procedure, what materials, make a conclusion. You write it out step by step. He's the guy who started that whole thing, so you can blame Galileo for that when you have to do it in class. He did not invent the telescope. A lot of websites will say he invented it. He was the first one to examine the sky with it. It was actually invented by the Dutch in 1608, but he used it to examine the sky. He also believed in the heliocentric, so his observations disproved the geocentric. The only difference between him and Copernicus really wasn't that outspoken. Galileo was very outspoken, and he went against the Roman Catholic Church. Even when they told him to, keep quiet and don't go out there telling people that the sun is in the center. Again, the Catholic Church wanted people to believe the earth was in the middle. But he went against the Pope. He went against the Catholic Church, and he went out and said, hey, I'm going to let everybody know. I'm going to make it public that the earth is not the middle. We are not in the center. It's the sun in the middle. And the problem with that was the church was very upset with him. In fact, the Pope summoned him to the Vatican. He had to go to see the Pope. The Pope said, I want to speak to him. And he ended up being put under house arrest. And that was during the later part of his life, the last 10 years. So for the last 10 years of his life, he had to stay under house arrest. And he ended up dying of fever at the age of 77, which, again, that was pretty old for that time. And, fever, today you say, oh, fever, ibuprofen, I'm good, or Tylenol. But back then, that they didn't have all that stuff. So, yeah, that's how he ended up dying, under house arrest at the age of 77. But he was persecuted by the Roman Catholic Church. The Pope was really angry with him because he spoke out. Whereas Copernicus, he disproved the geocentric, but he wasn't very outspoken. Galileo, he had a big mouth, and he just wanted to let everybody know, hey, this is the way it really is. Don't believe the church. I'll skip that page. That's not important. All right, so here comes Johannes Kepler. Kepler, again, is the student of Tycho. Tycho's his boss. There's two interesting ways, or articles, or I guess research, if you look it up, how Kepler actually ended up dying. The more dramatic version, I'll just sum up. Basically, what happened was Kepler and Taiko Brahe were working on these laws, these three important laws of planetary motion. And they knew these laws were going to change the whole thinking of how the planets operate. How do they travel? And they were about to come out with these laws. Now, this is the dramatic version. Supposedly, Brahe is upset with Kepler because Kepler's upset with Brahe. Brahe being his boss and Kepler being his apprentice, Kepler did a lot of the work. And Brahe was about to have a party at his house one night. So he's going to bring out to the people and make it public these three important laws. They're called the law of orbit, which we're going to talk about here today, the law of equal areas, and the law of harmonic motion. And so these laws are about to be public. And Brahe is about to say, they're my laws. But Kepler did all the work. Kepler was like the gopher boy. He did all the work. He did all the experimentation. And Kepler's mad. He's saying, hey, you're going to take the credit, but I did the work. And so supposedly they're at this party, and Kepler supposedly slipped some mercury poisoning into Brahe's drink. They would be drinking out of these goblets, wine to celebrate and have a party. And supposedly Kepler slipped a little poison into Brahe's drink, and Brahe dies. So he bumps Brahe off, and then the laws go down as Kepler's laws. That was the story up for quite some time. For many, many years, people believe that's what happened, that Kepler murdered Brahe. That's the drama. The actual situation changed in 2012. So in 2012, and it's not that long ago, right? As medicine got better, and forensics especially, they actually went and said, we have to solve this once and for all. And they went to Brahe's gravesite. They actually exhumed his body in 2012. They took it out of the casket, and they did a study on it, an analysis. And they actually found there was no poisoning left in his system, and that he actually died from a bladder infection. And it wasn't murder. He was not murdered. He actually died. And what actually happened then is, and they had some of this written in some form, but people again didn't believe it. Brahe was on his deathbed. The two were very close friends. They were not enemies. And that Brahe said, hey, look, I'm not going to make it. I'm going to die from a bladder infection. I want you to go down in the record in the history books as the person who came up with the laws. And they go down as Kepler's laws, not Brahe's laws. So he actually was a friend to Kepler. They were very close friends, and said, "Look, I'm not going to make it. You take the laws. They're your laws, and you did the work." So he didn't. There was no anger. There was no resentment, and that's how the whole thing went down. So this is the first law, and then I'm going to show this little video and then talk about it. It says all planets revolve. Revolve means to travel around the sun in an orbit shaped like an ellipse, with the sun located at one of what's called a foci, or a focus point. Foci would be plural, right? Focus point is one, foci is two. All planets revolve around the sun in an orbit shaped like an ellipse, with the sun located at one of the foci. Let me pull up this YouTube clip.